Welcome to this explainer. Today, we're looking at a truly massive leap for open source AI. And the coolest part? It's built entirely in India. Sarvam AI has just dropped their 30 billion and 105 billion parameter models, and we're going to unpack the whole shebang. We'll look at exactly how they built these models completely from scratch, why their architecture is so hyper-efficient, and how they're legitimately competing with the biggest tech giants in the world. I mean, this isn't just another run-of-the-mill tech update. It is an absolutely foundational moment for sovereign AI.
Okay, let's dive into this. Here's our roadmap for today. Number 1, India's sovereign AI milestone. 2, the architecture of efficiency. 3, global reasoning and agentic benchmarks. 4, the Indic language advantage. And finally, number 5, real-world AI in action. And trust me, we're going to look at some mind-blowing real-world applications later on.
Section 1. India's sovereign AI milestone. To really grasp the gravity of these new models, we have to recognize that this was a complete, full-stack effort. From the datasets to the training, right down to the inference systems, everything was done entirely in India, using compute provided under the India AI mission. Which naturally brings up a huge question, right? Can a relatively new Indian AI model actually rival the massive entrenched global tech giants? It's a classic David versus Goliath scenario. So how do they compete? Well, they do it by completely changing the fundamental approach.
Sarvam's underlying philosophy captures that approach perfectly. They say, we don't adapt Western models to India, we build from Bharat. And honestly, this is the thematic core of everything we're looking at today. They didn't just take an English-first model and awkwardly bolt on a Hindi or Tamil translation as an afterthought. No way. These models were created natively, right from the ground up, designed to deeply, intuitively understand India's incredibly diverse linguistic and cultural contexts.
Section 2. The architecture of efficiency. So how exactly did they build something so powerful without needing just, completely unsustainable amounts of compute? The secret sauce here is the mixture of experts, or MOE architecture. Think of it like a massive hospital. You wouldn't have every single doctor in the building crowd around a sprained ankle, right? No, you're routed instantly to the specific specialist you need. MOE works the same way. It scales up the model's total brain power, but for any given word or token, it only activates a sparse, specialized fraction of the network. This keeps the whole process incredibly fast and, crucially, cheap to run. Sarvam released 2 distinct models built on this exact philosophy. First up is the Sarvam 30B. This one is heavily optimized for real-time deployment and conversational use cases. In fact, it's what powers their Samvad conversational agent. Then there's the heavy hitter, the massive Sarvam 105B. This model features extended depth through something called multi-head latent attention, and it's designed specifically for really complex reasoning and agentic workflows, like running their Indus assistant. Now, what's really interesting about this slide is that 2.4 billion number. While the smaller model has 30 billion total parameters, it only uses 2.4 billion active parameters during inference. That is a massive juxtaposition of high performance against hyper-efficiency. You're basically getting the vast intelligence of a massive model, but with the running costs of a tiny one. It's a real game changer. Getting to that level of efficiency required a rigorous, fully in-house training pipeline. Step 1, pre-training on up to a staggering 16 trillion tokens, focusing heavily on reasoning, code, and Indian languages. Step 2, supervised fine-tuning using highly curated prompts. I mean, there's no scraping the bottom of the internet barrel here. It's all high-quality stuff. And step 3, reinforcement learning via an advanced asynchronous GRPO architecture. What this actually does is prevent the model from forgetting its instructions, a really common bug known as reward collapse. By keeping total control over the pipeline in-house, Sarvam gets total control over the final capabilities. Section 3. Global reasoning and agentic benchmarks. Now, the architecture sounds great in theory, sure, but the hard data proves these models aren't just efficient, they are globally competitive. Let's look at the heavy hitter, Sarvam 105B, stacked up against massive frontier models like Gemini 2.5 Flash and Claude 4 Sonnet. Take a look at the AMI 25 benchmark. This is extremely difficult competition-level math. Sarvam 105B scores an 88.3, just blowing past both Gemini and Claude. And on general knowledge like MMLU Pro, it easily stands its ground. Their strict in-house data curation and laser focus on complex problem-solving absolutely paid off here. And that efficiency story? It continues right into the 30B model.
Look at how it completely dominates its weight class against models like Gemma 27B and Olmo 32B. On Math 500, it hits a 97.0. On Human Eval, which tests coding, it gets a 92.1. It consistently outperforms or matches models that require way more active compute, particularly in areas that require really strict logical reasoning, like math and code generation.
Section 4. The Indic Language Advantage. We've seen the raw math and code scores, right? But the ultimate superpower of these models is their native mastery of India's incredible linguistic diversity. Sarvam evaluated these models across all 22 scheduled Indian languages. But here is the brilliant part. They tested them on both native scripts and Romanized scripts. Romanized text is how people actually type on WhatsApp or social media every single day, spelling out Hindi or Telugu words using the English alphabet. And against competitors, Sarvam models win about 90% of pairwise comparisons in these languages. It's literally an absolute blowout. The hidden secret behind that decisive win is tokenizer efficiency. See, Western models often treat Indian languages like a total afterthought, requiring tons of tokens just to write a single word. That causes bloat, high costs, and incredibly slow generation. But Sarvam built a custom tokenizer natively optimized for 12 different scripts. For low-resource languages like Odia, Santali, and Manipuri, this tokenizer is insanely efficient. It drastically reduces the cost and the latency, which makes Indian language AI actually highly practical for everyday use. Section 5. Real-world AI in action. Okay, technical specs and benchmarks are important, for sure, but let's see what these models can actually build and do. Can Sarvam 105B pass a JEE mains physics exam? For context, the JEE is one of the most notoriously difficult engineering entrance exams on the entire planet, and this brilliantly illustrates its power. When tested on the 2026 JEE main paper, the model achieved a perfect 25 out of 25 on pass at 2 for physics, chemistry, and math. It even solved the complex diagram-based questions perfectly, relying on just a text description.
But here's the best part. It doesn't just instantly spit out the answer. Sarvam developed an internal tutor mode that really shows off the model's deep role-playing capabilities. Let's look at an example. A student is struggling with the mean-free path concept in kinetic theory. Instead of just handing over the formula, the 1005B model patiently asks probing questions like, what physical factors make it harder for a molecule to travel? It actually guides the student to realize on their own how pressure and diameter affect collisions, helping them simplify complex math step by step. It essentially acts as an incredibly patient Socratic teacher. Beyond tutoring, these models can handle some seriously intense agentic workloads. Let's rapid fire through some demos. Web page generation. From just a single prompt, the 105B model built a fully interactive Pokédex that pulled live API data, and it even designed the stunning Sarvam landing page right from scratch. Conversational AI. The 30B model reliably handles real-time, telephonic voice banking queries in Hindi and Tamil without lagging at all. Competitive coding? Yep. It's successfully solving Codeforce's Div3 Python problems, which requires genuine, deep algorithmic problem solving, not just memorization. And get this, you don't even need a massive billion-dollar data center to run these. Sarvam optimized the inference stack right down at the kernel level. On high-end H100 servers, you're looking at 3x to 6x higher throughput. On mid-tier L40S GPUs, you get massive improvements that seriously lower infrastructure costs. Actually, you can even run the 30B model locally on a MacBook Pro with 20% to 40% higher token throughput. They have literally made frontier AI accessible at the edge. So, we've seen the unbelievable efficiency, the benchmark dominance, and those incredible real-world demos. But let's zoom out for a second. Think about this. What becomes possible when frontier AI natively speaks the language of a billion people? When AI isn't just an English tool translated poorly, but a system truly built from Bharat for Bharat. Sarvam has laid down the foundational infrastructure for sovereign AI here. The tools are incredibly powerful, they are open source, and they are ready to go. The real question now is, what are you going to build with them? Thanks so much for joining me on this explainer, and keep learning.